let us get going. Just a quick reminder, we did talk about this last week, but for those of you who weren't here last week, our lessons will continue during the holidays. So they will be at our normal time on Tuesdays and Thursdays. So from 6 until 7, you'll still have your quizzes on Thursdays. It'll be the same. Nothing will be different. The only thing that will be slightly different is that we're not going to do new topics. We're going to go over some questions from the harder stuff. So we're going to look at some of your hard topics, like specifically functions, and I think maybe some exponent work if there's time, maybe some simultaneous equations. We'll have a look and see what sections you were the weakest in, and we'll try and do some lessons on those. Okay, so that's what those lessons will be. We should have themes because it's the holiday. Like, I think we should all wear our pajamas or something.
And come with hot chocolates or something.
Yeah,
more, other
like
than
a hot chocolate pajama day. Who can have the fluffiest pajamas? We'll have a pajama fluff competition.
And something warm.
Yeah, something warm. Okay, so last week we looked at the sine graph, and today we're going to look at the cos graph. Now, a lot of the things that we're going to talk about, it's very similar to what we did with the sine graph. So a lot of the things that we're going to be talking today, it's not going to be as scary as the sine graph was because you've seen some of these things before. Okay, the thing that's really important for today's lesson is you need to have your calculator. So if you do not have your calculator with you, please run and go get it quickly and just get it because you will need it for this lesson. Okay. Cool. Okay, so our cos graph works the same way as our sine graph. When we have to write it as a function, we have y is equal to a cos x plus q. Okay, now what does the a tell us? What does the a tell us in these types of graphs? It's the same with your other functions, like what does the a in general, when we have a in a function of an equation, tell us? Amplitude, beautiful. The shape, yes. Okay, so Boucle, it's close. We don't have a gradient when we have a curve. We have gradients at a point on a curve, but we don't have a gradient. So whenever you have a curved graph, like a hyperbola, which goes like that, or an exponential or a parabola, none of those will have a gradient just because they're curved. Okay, but they do have a shape. So your A is telling us about our shape. It's also telling us, you're most welcome. It's also telling us about our amplitude. Okay, so that's what our A is telling us. And then the Q value is telling us what? Yes, exactly, A for amplitude. Q, there's only one answer I'm seeking here. Let's see if someone gives it to me. It is a constant number. It's not the y-intercept. That's my trap that you walked into. It's not the asymptote. We don't have asymptotes in cos and sine. Good. It is our shift. It is our vertical shift. So it's saying how much is my graph moving up or how much is my graph moving down. It's basically moving up or down like this. It's a vertical shift. Okay. So that is when we're looking at our cos graph. That is what it's going to look like. Now, when we did our sine graph, when we had a positive sine graph, we knew we were starting, let me just kind of move to the side a little bit over here. Don't worry, I will center again just now. When we were dealing with sine, okay, so if I had y is equal to sine x, oh, that line, I can't get away with it. Here we go. Okay. Our line started at the center, and then it went up, and then it went down, and it looked like that. It looked like a little wave, okay? That was y is equal to sine x. And when we had y is equal to negative sine x, then instead of going up to start, remember when this was when we were looking for our equations in the second graph, instead of going up, it went down first, and then it went up. And so it looked like that. Okay, so it went up first and then down, and positive and negative, it went down first. Now, cos is a little bit different. And because cos is a little bit different, I wanted you to draw both of these graphs so that we can actually see what's going on. So before I jump into anything, for anyone in this class, is this anyone's very first lesson with trig functions? And you're looking at this all and you're like, what on earth is going on? If you're embarrassed to say to the whole class, you're welcome to send Yolanda or I a private message. Okay, so Skylar, if you're feeling a little bit lost, please don't panic. Remember, the videos are online, so you can watch them on the Watobe website. We've had 2 lessons where we spoke about our sine graph, but I'll talk you through some of these steps as we're walking through them. Exactly. Yolanda is here. She is our TA. So basically, whenever you're needing help, if you're feeling a little bit lost, just send her a message and she'll be there. So down in your chat box, you'll see at the moment it says send to everyone in the meeting. You can choose to send it just to Yolanda, and then that message will just go to her. Okay, so let's go through how to figure out some of these things. If you're feeling confident with this, please go ahead. And if you're feeling confident with how to do it in the calculator, also feel free to do that. I will re-go over how to do it on your calculator once we've established this. Okay, so let's try and figure out what some of these different things would be. If we're trying to find this y value over here in this box, we're saying, what is that y value going to be if my x value is negative 360? So in our calculator, we're going to say, we want to know what cos, so you're going to write cos, and then the bracket's going to open. What is cos of negative 360? And then you're going to close the bracket. Okay, so you're going to have cos of negative 360 and close that bracket and push equals, and you're going to get the answer 1. Okay, so I want you to figure out what all of these would be for y is equal to cos x, and then I would like you to figure out what they would be for y is equal to negative cos x. So you can just do them on your side, and then I'll start putting them slowly into this table, but just start getting practice. It's really important to make sure you're putting in the correct things. Apiwe, how can I help? Hello? No? Okay, so try and fill these in on your side. And then we're going to draw these out. And then I'm going to show you how you can do this on your calculator. I'm seeing some good answers coming through though. We should be seeing something like this so far. Hopefully. And if you're struggling with getting this into your calculator, just let me know and I'll try and help where I can. Just try and set this up so long. Okay, cool. Let's fill in the rest of these. So then I'm going to have 1, I'm going to go back to 0, -1, 0, 1. Okay, so if you got all of those, that is great. Let's try and draw that graph. So now specifically for those of you who've never drawn a trig graph before, it can be, it's a little bit of a learning curve, but you will get there. You'll be fine. So let's try and work this through step by step. Okay, if I'm looking at this, that's telling me my x value is -360 and my y value is 1. Okay, so I'm going to take my x value as -360 and then my y value is 1. And I'm going to draw a point over there. Then I'm going to go down to 270, which is 0. That -180 is -1. At 90, it's 0. At 0 degrees, it's 1. At 90, it's 0. At 180, it's -1. At 270, it's 0. And at 360, it's 1. Now we're going to try and draw this. This is where we have to get our artistic sides working. Okay. What we don't want to see is we don't want to see a graph that looks like this. Okay, we don't want W's. We don't want W's and we don't want V's. We don't want that. Okay, what we want is we want to see a wave. So that's a top point. We're going to wave and then we're going to come down into our minimum and we're going to go up to our maximum and down to our minimum and up to our maximum. So we get this lovely, yes, we get our Drakensberg Mountains, the nice pointy ones, and then we get these lovely nice curves like the oceans, which is what we're wanting. We don't want Drakensberg Mountains, we want waves. Okay, it's not the prettiest of waves, but hopefully it will be something that you can see. Oh no, I lost your calculator. Okay, you're gonna have to just try and work with us the best you can, but if you don't have your calculator, it will be a bit tough. So this is if we're just looking at y is equal to cos x. So all we've done so far is we've put those into our calculator. We found out what their x and y, well, what their y values are, and we put it in. So in this case, our a value is just 1. It's just 1. Okay, so our graph hasn't shifted at all, and it has an amplitude of 1. Who thinks, I'm going to try and zoom out a little bit so you can see my sine graph up there. And for the moment, you can ignore this one. Who thinks they can tell me one big difference that they can see between that sine graph and this cos graph? One big difference. Come on, don't be scared to take a shot. Doesn't matter if it's wrong. You know I never mind if it's wrong. Beautiful, Tariq, that was exactly what I was looking for. Okay, on our axis over here, our sine graph started on 0. And on our cos graph, when we're on our y-axis, it starts at 1. Okay, so when we're dealing with our sine graph, it starts on 0 because sine of 0 is 0. But cos of 0 is 1. It's not 0. And so when we're on our cos graph, it always starts at its maximum. Or it starts at its minimum, but we're going to talk about that now. So if we have a graph of y is equal to cos x, it's going to start at its maximum. So for example, if I gave you y is equal to 2 cos x, where would that graph start? What would be its maximum? Where would it start? On its y-axis. It would be at 2, exactly. Okay, and if I had y is equal to 4 cos x, where would that one start? At 4. Okay, good. We are getting somewhere. Nice. Okay, so basically it's looking at where it starts in our amplitude. Okay, when we're not dealing with shifts, because when shifts come into play, we have to be careful a little bit. Okay, so that's just looking at y is equal to cos x. Dealing with y is equal to cos x, let's talk about a couple of things. So we haven't dealt with y is equal to negative cos x just yet. I will show you how to get it onto your calculator. Don't worry, I'll show you next, okay? Let's talk about a couple of things here though. Let's first talk about what our range is. Remember when we're dealing with our range, we write our minimum value and we write our maximum value. So for our range, what would it be of this purple graph that you're seeing there? Beautiful. Nice. Okay, just be careful, Tariq. They need to be the square brackets because we're including those numbers. It's allowed to be -1 and it's allowed to be 1. And so because it is allowed to be, then we're going to have the square brackets. If we can't include them, we're going to have curved brackets. Beautiful. Okay. What is a period of a trig graph? What does it mean to be asked the period of a trig graph? It is 360, but what does it mean? Like, what does it mean? So not necessarily the end value, because sometimes it can go past that value. The full curve. Good. Okay. So when they're asking you for the period, what they're asking for is how long does it take for it to complete its full wave? And in sine, it's a little bit easier to see its full wave. But in cos, we're at this maximum point. How long does it take us to get back there? It's taking us 360 degrees. Okay, so period is saying how long or how many degrees does it take? Let's write that out. How many degrees for a full wave, basically. Okay, and it's going to be 360 degrees. Good. Okay, so we know our max, we know our min, we know our period. Our amplitude we spoke about was 1. Cool. Let's now have a look and see what cos of negative cos x is. Now for this one, I want you to just show you how to go through it on your calculator again. So for some of you, this will now be the 3rd time you're hearing this. For some of you, it will be the 2nd time, and for some of you, it will be the 1st time. So Tariq, domain in trig graphs, if they asked for the domain of y is equal to cos x, it's just going to be x can be any real number, because it can be any real number. But they'll often give you a restricted domain. And so then you have to be careful with what they've restricted it to. So often domain is not one that they like to ask when it comes to trig graphs, because it's sort of counterintuitive, but we'll talk about it a bit more. But generally the domain of a cos graph is x can be any real number. Okay, so let's have a look at how to do this on our calculator. Grab your calculators. What we're wanting to do is we want to get into table mode. So the first thing you're going to write is you are going to write mode. Okay, well, not write, you're going to type mode, and you're going to want to choose table. Okay, so you're going to choose mode, you're going to choose table. Now, when you're in table mode, it's going to say f of x is equal to, and you're going to put in the equation that you want. So we want the equation negative cos x. So we're going to type in negative, and then we're going to type cos. And now in order to get this x in here, to get that x, we're going to push alpha, which is the top right, well, on the left-hand side. It's that button over there that says alpha. It's pink. It says pink above it. You're going to push alpha. And then you're going to push just above where the bracket is. You'll see there's a little pink X above it. You're going to push that. So you're going to push alpha, and then you're going to push the bracket that has an X above it. Okay, and that's going to give you your X, and then you're going to close that bracket. So on your calculator, it should look like that. F of x is equal to negative cos, and then in brackets, big X. Is anyone needing help with getting up to that point? Have I lost anyone yet? If I have, let me know. Good, I'm glad you got it. Good. If you're needing help, it's better to sort of ask along the way with these. Okay, Skylar, where did I lose you? Okay, let's try and talk through it again. So you're going to push mode on your calculator, push mode, and then push the option that says table. And then your calculator will say f of x is equal to. So now you're going to push minus cos, which is going to open a bracket. Then we're going to push alpha. And then we're going to push this little bracket, which has the x above it, x. So inside your calculator, it will now say f of x is equal to negative cos and then x, and then we need to close that bracket off. Asia, are you in a sharp? The sharps are a bit more complicated. Yeah, I'll write up a little thing. If you're not using a Casio, if you're using a sharp, they can be a bit more complicated. I'll try write up a little step by step and get it for our lesson on Thursday. I'm just making myself a note. Okay, then we're going to push equals. So we've got f of x is equal to negative cos of x in brackets, and we're going to push equals. And now your calculator is going to say, well, what about g of x? Okay, but g of x we don't need because g of x is another equation which we don't need. So we're just going to push equals to get rid of g of x. Okay, so Suzanne, once you've pushed alpha, then you're going to push the button that has a little bracket and a little x above it. That's going to give you this x in the middle. And then you're just going to close off that bracket and push equals. Okay, so we're going to push equals. Then it's going to say g of x, and we're just going to push equals again. And then it's going to say start with a question mark. That start is asking what is the smallest x value? That's what that's asking. So what is the smallest x value? And in our case, the smallest x value is negative 360. Okay, so we're going to write negative 360, and then we're going to push equals. So we're going to type in negative 360, and we're going to push equals. Okay, then it says, what about end? The end is the biggest x value. So in this case, our biggest x value is 360. So we're going to type in 360 and equals. Yes, so it will say 5, but we just type in what we want it to be. So you just type in 360 and then push equals. Then it says to you, what must I step in? So basically, how many degrees must I jump each time? And when we look at this, every time we jump, we're jumping in 90 degrees. So we're going to say, well, we want you to jump in 90 degrees. So we're just going to say 90 and push equals. And then what you land up with on your calculator is a table with all of the information that you would possibly need. So on the left-hand column, you've got your x values. So it's negative 360, negative 270, negative 180. And on the right-hand side, you've got all your y values. So negative 1, 0, 1. And if you scroll down, you will see the rest of them. So we can now fill this in really easily. We can say, well, negative 360 was negative 1. Then it was 0. Then it was 1. Then it was 0. Then it was negative 1, 0, 1, 0. Negative 1. All with our little calculator. How nice is that? It's a nice little tricky trick to help you in these situations.
Yeah,
and although it
nice
seems
and easy and it's
exactly
exams.
Very helpful for exams. So although it seems like it took like a little bit of a longer process now, it's because you're just learning. But as soon as you know it, you'll be fine. And it'll start clicking in your head. And we'll do some more as we go through today. See, simplifying your lives, making lives easier. Okay, cool. So let's plot this one quickly. This one now says that at negative 360, it's negative 1, and then 0, and then 1, and then 0, negative 1, 0, 1, 0, negative 1. Okay. So we land up with this dude over here. We land up with this green guy. Oh, okay, so now if your calculator's on f of x and you're stressed, it's just because you're in table mode. So now you're just going to push mode and you want to be in comp. So you're going to push 1. and that will take you off the f of x mode. Okay, so now we land up with this green graph, which is y is equal to negative cos x. What is the biggest difference that you can see? I know there's quite a few differences, but what is the biggest difference that you can see between the purple graph and the green graph? What is the biggest difference? It does kind of look like DNA.
So now what? I give it to you. It looks like DNA.
It does. It really does. It is. It absolutely has been reflected. That's exactly what's happened. It's been reflected over the x-axis. It's 100% what it's done. What's the big difference? Oh, yes, Bula, yes. Okay. So where cos x started at its maximum, negative cos x starts at its minimum. Okay. So the same way that you were able to tell me that y is equal to 3 cos x, you were able to tell me, well, you know that that's going to start at 3. Okay. If I gave you y is equal to negative 4 cos x, then that's going to start at negative 4. So it's going to start either at its minimum or its maximum, depending on its amplitude. It did. It M with the W. Okay, so this is just sort of like a vague, like an overall look at what our cos graph looks like. I'm just going to try and squeeze as much in here as I can. I'm going to move the sine guy away. So if you're wanting a screenshot, you can get one. Okay, so time for screenshots is now, and then we're going to move on and we're going to start drawing some of these.
Take a screenshot, guys, and forever hold your breath.
Exactly.
Nice graphs. I love these colors.
They're so nice. They really are. They make maths beautiful. The test that you write with Watobe, you do on Thursdays, and you will do it online. Yeah. So our lovely Yolanda will give you the link on Thursday, and you'll be able to get it.
Yes, I will, guys. I can't wait.
Another free time.
Quiz.
I think this test is out of 14. Okay, oh, it's brain break time. Okay, now I'm just gonna, my grade 9s were horrified. They told me that it was way too easy, so I'm sorry in advance. I apologize for how easy your brain break for today is. I thought it was gonna trick more people. And
yeah,
I was
let's
clearly
see
wrong.
how the grade 10s take this.
Yeah.
I'm interested to know.
For those of you who are new, a brain break is just something silly that we do in the middle of the lessons to try and get your head a little bit of a break from what we're doing. But yeah, it's not anything stressful. Okay. I would like to know what the 2 question marks are.
Let's go, guys. Oh,
Not 30.
come on, my grade 10s. Let's go, my
Kevin,
people.
1.
Pressure.
Where did 1 come from?
Oh, why does it look like everything? These people just know a lot.
No, it makes me so sad. Okay.
Oh,
so
guys.
many of you have gotten it. The answer is definitely 0, 3. For those of you who have not gotten it yet. You're multiplying these together. So I know it was too easy. I'm sorry. Okay. So 5 times 3 is 15, and then we flip it around, so we get 51. 5 times 5 is 25. Flip it around, and you get 52, and so on, so on, so on. Suzanne, if you're still struggling with getting it into your calculator, don't panic. We are going to do more calculator work with it today. And you can always watch the videos again until it's clicked. Sometimes it just takes a couple of watches. Did I miss anyone else's comments in here? No, I don't think the grade 9s are smarter than you. I think you're still just fine. Ah, I see that yawn. I see it. It's hurtful. Very hurtful. Also, just so you know, I've become an expert at drawing SpongeBob smiley faces. So just throw that into my resume. Super Seto, how can I help? You just need to unmute on your side over there. Okay, I'm going to keep going. If you figure it out, then we'll get there. Okay, so let's have a look at this question. Oh, you're feeling lost? It's okay. We're going to go through them slowly. Don't stress. Remember, we've already had 2 lessons on this. And so if this is your first lesson, I can understand why it's feeling a little bit stressful. But all of the videos are on the Watobe website. I really recommend you go and give them a watch. And it will start making things fall into place, I promise. Don't panic. For those of you where this is your first lesson, please don't stress, I promise. Okay. Okay, let's have a look at this one. No, your brain will not die. Let's try and break this up a little bit. Let's try and see what's going on. So let's read the question step by step. Sketch the following graph for when x is an element of 0 to 360. What is this telling us? What is that information telling us? Why do we need it there? What does it want to tell us? It's telling us something important. The period is 360. Good. Palesa, yes, absolutely. It's starting from 0. This is telling you what the domain they want you to use is. Okay, so they are restricting your domain. They want you to say that 0 is where we're going to start. And 360 is where we're going to end. Okay. So if we were going to draw this, for example, we would just draw yourselves a little line and try and draw this on your sides as well to get some practice. Okay. This is our x-axis. This is our y-axis. It's telling us for our x-axis, it wants us to start at 0 degrees. And then it wants us to go to 360 degrees. And that's where it wants us to stop. So we don't want anything more than that. So our y-axis is on the side because we don't care about any of the negative x like values, because they're only wanting us to start when x is 0 degrees. So we don't need any of the negatives. We don't need negative 90 or negative 180 or negative anything. We can start. So that's why I've just moved the y-axis a little bit to the left. Okay. Okay. So in sine and cos in grade 10, your step is always going to be 90. It's going to change in grade 11, but for the moment, it's always going to be 90. All right, let's try and chuck this into our calculator. If you're not using your calculator, then just draw yourselves a little table. Ooh, guys, my line skills are not great tonight. Let's have a look. Okay. Just get yourself a little table with your x and y. We care about where x is 0, where x is 90, where x is 180, where x is 270, and where x is 360. Okay, and you're going to type this equation into your calculator, and you're going to change that x value. So when that x is 0, when that x is 90, when that x is 180, so you're going to change it as you go along. Okay, if you would like to try it in your calculator, let's try in our calculator. So calculator, mode, table, type in your equation, 2 cos, opens the bracket, alpha x, close the brackets, plus 1. That's what it should look like. Equals. G of x, we don't care about, equals. Start, where are we starting? What's our starting point? 0. Beautiful. Good. What's our end point? Yes, 360. Good. Step 90 equals. And then they have all of our answers for us. So see, it's getting quicker. But at the more you do it, the quicker it'll be. So at 0 degrees, y is 3. At 90, it's 1. At 180, it's -1. Then we've got 1 and 3. Oh, okay. So the y would move into the middle if the domain that they were asking, if the domain was like anywhere in the negative. So like if this said -180 to 180, for example, then it's going to change. But we'll get there. I have other graphs where it does that. I'm glad that this is clicking for some people. And if you're not feeling like it's clicking and you're like, why is this clicking for some people and it's not clicking for me? Remember that some people have done this in class. Some people have been in this lesson for like the last week. So don't be hard on yourselves. Everyone will get there when you need to. Georgia, how can I help?
Hi, ma'am.
Hi.
So I don't understand why do you sometimes use the mode version on your calculator and then sometimes you just use the normal way? Like, is there like a certain time when you're supposed to use the calculator for like mode and setup, and then is there another time where it's just use your calculator but it's not for mode and setup?
I would always use my calculator in these situations because it would just be quicker, the mode setup, and just do it as a table. But if your calculator is one of the ones, so basically if you're not working with a Casio, if you're working with a Sharp where it can be a little bit more complicated, then sometimes it's easier to just work with the actual equation and inputting the different x values.
Thank you.
Sure. The other question that came down about the table, it's just for yourself. You don't have to draw it. It's just there to help you. Pumalele, can I help? Okay, now we're just going to fill in these different values. So at 0 degrees, it's 3. So I'm just going to put my different values in there. At 0 degrees, it's 3. At 90, it's... Oh, hi, sweetheart. How can I help?
So sorry, I just got confused there.
No, it's okay. Yeah.
I want to ask about the domain and period. Is it the same thing or...
No, so period is how long it takes for the curve to happen, and the domain is all possible x values. So in a cos and sine graph in grade 10, your period is always going to be 360 degrees, but your domain could be different.
Oh, okay.
Okay.
Thank you, ma'am.
No problem. Okay, it does look weird. Cos graphs often look weird to me. I think that they're the ugly stepsister of the sine graph. Actually, both sine and cos are the ugly stepsister of the tan graph because the tan graph is a magnificent beast. Okay. And tan graph brings in asymptotes again, and we all know how I love my asymptotes. So we get this glorious little weird upside down hill. Yes, the period will remain 360 even if the graph ended at 270 because the period of a cos graph and of a sine graph is 360 degrees. Until next year, when we start messing around with your period, it stays as 360. So this is what our graph should look like. So we're just plotting the points that we had over here in this table. The +1 definitely needs to be outside of the bracket. You won't get the right thing. I was just saying it's the ugly stepsister. Like from Cinderella. Okay, and that's our graph at the moment. Okay, so now I want to talk to you about a couple of things. I want to know what is my minimum value. -1. Yes, minimum is how low does my graph go? How low does it go? That's my minimum. Okay. My maximum is how high does my graph go? What is my maximum? It's 3. Okay. If we know our min and our max, we know our range because our range is our min to our max. Mokukubale, how can I help?
Hello, ma'am.
Hi.
Ma'am, I just wanted to ask if they give you a graph like just like you give us and they say determine the numerical value, what do they mean and how do we find it?
The numerical value of a graph.
Yes, ma'am.
I genuinely have no idea. I think I would need to see the question.
Oh, okay, ma'am.
Maybe try and take a picture of it and then show me on Thursday.
Ma'am, it's in the book. There's this book that they gave us in class. So they gave us the exercise. So here it says determine the numerical value of A, and there's a graph.
Of A. Okay. So if they're asking for the numerical value of A, they're asking for what is basically in this graph, A is 2. Because A is your amplitude. So they're asking what is your amplitude of the graph.
So ma'am, when they said the numerical, they mean the amplitude.
Yeah, when they say no, they want the numerical value of A. So they're saying what is the number? So numerical is just a fancy word of saying number. So what is the number that is A?
Okay, thank you so much, ma'am.
Sure, no problem. Sia, hi.
Hi ma'am, how are you?
Good, and you?
Good, thanks. Ma'am, I'm not sure if I'm gonna confuse people, but ma'am, when we get like the max and minimum value, aren't we supposed to times it with 1/2?
No.
Or is that for
Why?
sin?
No, for neither. The only time we divide something by 2 is when we're looking for our amplitude, when we're looking for A.
No, like ma'am, multiply it by 1/2.
But why would you be multiplying it by a half?
Ma'am, I don't know, man. That's what we learned yesterday.
So, okay, the only time we bring in a half is when we're looking for A. So if I'm looking for A, then I'm saying my max minus my min, and that I divide by 2. So the same way of writing that is if I said a half times max minus min.
Oh, okay, ma'am.
That's the
Thank
only
you.
time the half gets involved, though.
Okay, ma'am.
Hope that helps. Okay, so if we're looking for our amplitude now, in these ones, it's easy because we know that our amplitude is 2, okay, because it's been given to us in the equation. Our amplitude is 2. But if we wanted to work it out, we look at our maximum value, which is 3, then we minus our minimum value, which is -1, and we put that all over 2. So that's 3 plus 1, which is 4 over 2, which is 2. So that's just a different way of finding out your amplitude. Don't worry about any of the words with oscillation or any of that. Don't panic. The words that we care about at the moment are amplitude, our min, our max, and our range. Those are the only words that we care about right now. Okay. All right. Let's try and I'm going to let you try the next one and see how you go. Which one do I want to do? Yeah, this one's fine. Okay, so now for this one, be careful. It's telling us our domain is between -90 and 360. Okay, so when I'm drawing this, oh, hello, it's a very big axis. When I'm drawing this, I do need to have some negative y values. Oh my goodness, this graph does not want to draw. Okay, let's try again. There we go. So I need some negative y values, but I don't need a whole lot. So we would say that's 0, that's -90, then we need 90, 180, 270, 360. Okay, so something like that. Can you all please try this for me? Just try this for me. And we'll see how close to my graph they'll end up looking. So you're welcome to use your calculators to get these numbers, or you can make yourself a table. And hopefully this practice of putting it into your calculators is making it a little bit easier and you're getting faster at it.
Yeah, I hope it is helping. It should be, because it's faster when you use the calculator method.
Fast.
Calculator, yeah.
You shouldn't be needing to round off. You should always get nice whole numbers. If you're a sharp calculator person, I need to put some, I need to look into it. So I have written it on my notes so that I can have something written up for you guys on Thursday. See if there's a quick way to do it on sharp.
Lonella's on fire. She's done already.
Nice. Should I go to my camera? Do you want to show me some of your graphs? If you have finished your graph, you're welcome to hold it up for me so I can have a look-see.
Sorry, Lonella. He's done already.
Oh, Skylar, I'm seeing some things happening. I like it. I like it. And it's your first time and you've already got a drawing. Woo! Simi, what is happening there? You look far too comfortable for doing maths. I see a rope. I don't see a paper or a calculator anywhere. No,
It's so comfortable.
too comfortable to do maths. That's what I say. Too comfortable to do maths. Okay, Lunello, I'm seeing some good things. Canva, look, your curves are getting so much better, Canva. That is like a legitimate nice curve that I am seeing. I'm not seeing the Drakensberg Mountains. Arakanisa, I'm liking that as well. Asanda's got a whole party happening over there. There's like 21 people in that camera.
I see. I said he's holding a very nice party.
Little maths party over there.
We want
Little
to see
study
the graph.
session. Buchle, just be careful. I think some of them are a little bit too close together, but it's not looking terrible at all. I think some of your lines are just a bit too close. Okay. Cool. Okay. I'm going to start drawing this guy. So, yeah, Canva was a huge improvement. It really was. Okay, so if we were to do this on our calculator, I'm just going to quickly put our values over here that we would see. Oh, it just did it. Oh my gosh, that's a whole function. I wonder if it's... Guys, the magic of this program. Look, I can draw a messy triangle and it made it into a neat triangle. Oh my gosh, I'm amazed right now. Okay, I'm going to try focus now. Focus after that amazement. That blew my mind. Negative 90, 0, 90, 180, 270, 360. Okay, so I've just done it on my calculator over here, but you can do it manually if you're wanting to. So we get negative 2, negative 3, negative 2, negative 1, negative 2, negative 3. Okay? I was amazed. Okay, no, you see, this is another one of the words that the youth say that I don't fully understand, so I'm scared to use it in case I use it incorrectly.
Don't use it.
Okay, so I'm just going to extend that a little bit. All right, and we need this to be negative 1, negative 2, negative 3. And let's draw this in. So we're going to have negative 90 and negative 2. 0 and -3, 90 and -2, 180 and -1, 270 and -2, and 360 and -3. Okay, so we're going down to our minimum. We're slowly coming up to our maximum and then going back down to our minimum. And we get this glorious, glorious little graph here. Guys, don't panic with words like oscillate. Oscillate are talking about the movement of the shape. It's not something you need to focus on or stress about, I promise. Okay. Things I care about is, what is my min? What is my max? What is my min for this graph? -3. Good. Max. -1. Yes, which means my range is what? And please, when you type in your range, I want you to write it in properly. So I want to see the brackets that should be involved. Yes, Tariq, 5,000%. Okay, so the y-axis are these values here. So that's when you actually input this equation with different x values. Those are the y values that you get. Calculate. I said a calculator. I meant to say a caterpillar. A caterpillar born anew. That's great.
Caterpillar.
I love it. Okay, so our range is -3 to -1. Skylar, I'm all yours. How can I help? I think something's happening with your mic, so we can't hear you clearly. It's sort of coming through as a bit of a buzz.
I think he's asking, how do you do the range?
Oh, okay.
The
Well,
range.
your hearing is much better than mine, Yolanda. So the the range is basically asking, what are my possible y values? That's what that's asking. What are the possible y values? Okay, and our possible y values are, that's the highest it can go, and that's the lowest it can go. So my range is that part in between. So the lowest it can go is -1, oh, -3, and the highest it can go is -1. Hopefully that made that a little bit clearer. Okay. Okay, so we've got min, we've got max, we've got range. Our period would still be 360. The domain, depending on how they ask the question, the domain could either be between -90 and 360, or it could be, x could be any real number. So it depends on how they ask the question. Do we say y equal to max? So you can, for this, you could also say y has to be, oh gosh. No, I don't want to be there. Okay. Y has to be less than or equal to -1 or greater than or equal to -3. So you could also write it like that. But when you're saying y has to be less than or y has to be greater than, generally that's when you're looking at parabolas. Okay. Coolio. Min, max. Okay, what's my amplitude in this question? What's my amplitude? Just going to wait till a few more answers come in, and then I'm going to tell you who's right or wrong. So some people are saying 1, some people are saying -1, some people are saying -3. I'm going to write down all of our answers so far. -1. So there's some of you who are correct, and some of you who are not correct. Oh, my screen just stopped sharing. That's so rude. Maybe that was a sign that it didn't want to be on anymore.
It's like my time is up.
It's like I'm done. It's fine. It's okay. So for the answer there, our amplitude was actually 1. So even though the A was -1, the A is just telling us where our shape is of our graph. So it's telling us we're starting at a minimum. It's not telling us we're starting at a maximum. So we started at a minimum, but the amplitude is looking at your max minus your min over 2. And that's always going to be a positive number. So your amplitude is going to be 1. Okay, let's do this one last question, then we'll call it a night. Nomandla, how can I help? No? Okay. Well, on
Skylar,
that
I
note,
hope you did get that because
yeah.
question. So I hope that you did understand. Hey, Skylar.
Yeah, no, guys, no one can see my screen. My screen has died, but I figured that since our time was up anyway, there was no point in trying to recover it. But okay, your amplitude is always going to be positive. But your amplitude, because your amplitude is looking at your maximum minus your minimum divided by 2. So in this case, it was -1 plus 3 over 2. So you're still going to get a positive answer, but amplitude is always positive. Okay. And on that note, I'm going to send you over to Yolanda, and she's going to talk you through this little poll, and I'll see you on Thursday.